Thank you. Thank you for having me. So let's get started. So first of all, thanks so much for being here today. I'm tuning in all the way from Singapore. So this is one of the projects I've been working on with a bunch of folks from Google. And we are excited to share with you things that we are working on about streaming ingestion using Dataflow. So let's get started. And yeah, this is me. Daniel actually be through this, so I will just skip this for now. So a little bit of backstory before I get started on this is that the project is part of this bigger project called Fraud Finder project. So we've been working on this for showcasing data to machine learning journey from all the way to getting the data in ingestion using streaming ingestion, batch ingestions, and things like that. And then we train the machine learning model all the way, and then we serve it at the end. So if you want to find out more, you could go to this link and check out our Fraud Finder projects. It's all open source. It's all self-directed learning. So you could just go through step by step, and you could be able to do it from start to the finished. So, the moral of the story is like the data that comes in is pretty much very simple. So we have customers who is purchasing items using their credit cards, and that sort of generates an event, and we are capturing those events into a pub subtopic, which is like a streaming data recorder. And we have this kind of transitions that coming out from those events: transition ID, transition timestamps, customer ID, terminal ID, and the transition amount. So each customer will have one ID, and of course, each terminal will have one ID. And based on those, and also it depends on the items that you purchase, you will have a transition amount, which is 930 for this case. So using these 5 columns, we have to create something like this. So our goal is to use the data, train a machine learning model, and determines whether each transition is a fraud or actual transition made by the users. So having those 5 columns is not enough. We have to create more features. In that manners in machine learning context is called feature engineering. So in machine learning workflow, we have data collection process, we have feature engineering process, we have model building and model serving process. For this talk specifically, I'm just going to highlight this feature engineering and the streaming feature engineering part using Apache Beam. And those other things like collection, building, and servings is out of scope for this particular talk. But if you're interested in it, you could go back to the Fraud Finder repo and take a look on how we architect the whole thing and how everything works perfectly all together. So before I go deep into the code, let's talk about data a little bit. So data in the past used to be low in gigabyte, right? It can fit into one simple database and everything works as it is. And nowadays, we have big data to handle. So different days may have terabyte to petabyte data, and there's a lot more data coming in per day, right? So we have to find a way that can manage this kind of huge amount of data efficiently. And not all data are stationary. So due to recent popularity and then the process of having more stronger hardware and things like that could potentially enable us to process streaming data. So we have data that's streaming in from time to time, and we have to find a way that could process streaming on the fly instead of waiting maybe like daily or monthly or weekly interval. Now we can process things on the fly. So, and of course, streaming data also have some, downside to it. Sometimes the data can come late from, like, let's say 8 a.m. It should arrive by 8 a.m., but some of the data might be delayed due to network condition, due to the hardware condition, various factors that it can cause delay, and it might arrive in the future. So how do we know this kind of delay, and how do we have to mitigate this delay kind of things? And sometimes we don't even know whether the data that delay will arrive or if there are any delays data in the pipeline. So streaming data comes with that kind of challenges, and we have to find a ways to solve this in order to process the streaming in real time. So my requirements for the project is to create more features. So in a way, like more aggregation features for machine learning to learn from. So I choose 15 minutes, 30 minutes, and 60 minutes interval for each customers and each terminal. We go back and find the number of transition to the number of amount and the average amount that transacted within those three interval. The reason I'm choosing 15, 30, and 60 is just arbitrary. Based on what I see is pretty much based on the use case. So if your terminal is being transacted very frequently, you might want to consider reducing the time. If your terminals or customers are not transacting very frequently, you could increase the interval maybe to 1 hour, 2 hours, 3 hours kind of thing. So for this case, we are using 15, 30, and 60 minutes. And what I was trying to work with streaming data, there's a few challenges that I face. One is not having a proper ending or beginning, because streaming data is always on the go. And some records can arrive late, and it may or may not arrive at all. So I need to find something that can cater for that kind of arriving late data. And another thing is the amount of data that coming into the system is not predictable, right? So if you have a campaign run by marketing teams where you have a lot of discount voucher being distributed out, a lot of people, a lot of customers might purchase certain type of items, then it sort of create more transactions and the more amount of data will come into your pipeline. So you need to be able to handle those workload. Also, because this is streaming ingestion, I need to process data on the fly. I can't wait for it to finish streaming maybe day or weeks or months. I have to do it right here and then. So I look for things, right? What are the tools that we can use to ingest streaming data? And I found Apache Beam. So I'm very new to Beam. So I have been like machine learning engineer for a while, but I have not been touching Beams for my entire career. So I started learning Beam about 2-3 months ago. So the interesting things about Beam is that it's open source. So I could go and see how things are implemented. And of course, if I want to, I could also contribute to it. And one thing that I like about Beam is that it has the unified programming model for both streaming and batch. So I don't have to create multiple pipelines for batch and streaming. I just need to have one unified programming models to work with both streamings and batch data projection. So I just need to change the source, and all this transformation that I'm going to do, all the feature engineering that I'm going to do will be the same regardless of whether I'm using batch or stream. And it also supports large-scale data processing, right? We could scale it out using like more machines and things like that. So it's quite interesting, and I wanted to just give it a try. So this is how typical Beam's code look like in Python. So I'm a Python developer, so I use Python day to day to train machine learning models and things like that. So I don't go straight to Java code. So I try to use Python as much as possible to create Apache Beam. So luckily we have the Python API from Beams to create pipelines. So this is how the code looks like. And we have pipeline creation code. We have a group by key. We have map to join all the works that we aggregated, and then we can bring the result. So the output that you see from this particular piece of code will be Google Cloud is awesome. And so how Bing use the underlying technologies in Beams to process streaming data is by process into time block. So there's this windowing functions that Bing support. Instead of streaming, because streaming has no end, so they create an arbitrary end to process all this data into time blocks. So instead of querying from start to the end, they will just say, I will just query in this time block. So whatever comes within this time block, I will process, and then I move on to the next time block. So in this case, we are processing in 2 hours time block. And there's functions from Beams that is called fixed window. So this is windowing functions that you can split your streaming data into chunks. So in this case, we are splitting by 10 minutes interval. So every 10 minutes, if I'm using this fixed window, every 10 minutes, the Bing would process all my transformations and engineering steps for that data that arrive within that 10 minutes, and it move on to the next time window. So every 10 minutes, I would create features, right? So the use case for this fixed window is to calculate number of transaction, average transaction within that time block. So my requirement is slightly different from this, because I would want to create features for each records, not for one time block. So I need to explore further. So I tried using this thing called sliding window. So sliding window is different type of windows, slightly differ from the fixed window. The difference is that it can stack into duplicate records. So every 10 minutes, I'm going to process something, but with a 5 minutes overlap. So this is used for calculating things like moving average for each transaction amount within the time block with an overlap of X number of minutes. So in this case, I'm trying this 10 minutes block with 5 minutes overlap. So every 5 minutes, it will trigger. And every time it triggers, it will calculate for that 10 minutes interval block. So this sort of like fix my 50% of the problems, because I could have very small intervals of overlap to be able to calculate for my features. But this is not enough. So I need to explore a little bit more to be able to get what I want. And there's another windows that we have, which is session window. But session window is pretty much used for things like calculating the user session, number of click, number of actions, because it goes by, it split the sessions by measuring the gap between the continuous sections. So in this case, this particular user one, it doesn't have like a 5 minutes interval break between these blocks. So they consider all these things as one sections. And if it has less than more than or equal to 5 minutes, it was split into different sections. So same thing for user 2, because they have more than 5 minutes interval within these two activities. So they will just check it into 2 sections. But this is not exactly what I want. This is more used for calculating the clicks and action for the user for a visit within that particular section. So I end up trying to use sliding window, but with an offset and 1 minute interval. So every 1 minute, my bin pipeline would trigger, and it will read back to 1 hour section, get aggregation data, then I merge it back to the newly formed data that we have. So every 1 minute, I have a 1 minute records that is fresh. Then I will get like the past 1 hour data, get aggregation of all the features that I need, then I do a left join. So by doing that, I created a feature set that can work for machine learning model. So I will show you the code, and it might be a little bit easier to see from the code if you have been experienced before. So with using this bin, sort of solve my 2 problems that I have, arriving late and also having no beginnings and ending. Because of offset, it will just calculate the beginning for me from the pipelines, and it will just create it nicely. So 2 things that we still need to solve is the unpredictable amount of data. So I need to have like an elastic sort of ways to scale my servers. And also I have to process it on the fly. So my process have to be monitored throughout, right? 24 hours, it has to be running. So because I'm from Google Cloud, Dataflow also uses beans at the backend, and Dataflow is managed pipeline. So it's fully managed data services. It's also provide automated provisioning. And so you could have like settings of minimum number of workers and maximum number of workers, and it will scale based on the workload that you provide. And of course, it's also reliable and have a consistent exactly one processing. So you don't have to worry about processing multiple things in a multiple way. So don't have duplicated processing for that. We also use Apache Beam SDK as backend. So most of the open source contributions and the new updates from the beans get adopted to Dataflow. So you can sort of influence the innovations in Dataflow by contributing to Apache Beam's SDK. So using Dataflow, I was able to solve these other two problems that I have, the amount of unpredictable amount and also needing to process data on the fly. So now let me quickly go into the demo. So this is the demo that I have. I have put into the GitHub, so you could take a look at all the code that I have. So I will be using Colab to run the code, but if you are on like Google Cloud, you could use the Cloud Notebook to run it. So basically, this is what the notebook looks like. I will install Apache Beams, and then I will import the necessary imports. So here we're just using pipeline options, combine functions, and min combine functions. So if you're from Spark background, you should be able to know what combine functions are. It is basically just to like count is just count, right? From the group by function, you just count, and then find the means is just find the means. So first of all, I need to define my minutes window. So I'm using 50 minutes, 30 minutes, and 60 minutes. After that, I have to convert them into seconds because Beam pipeline works in second value instead of minute value. Then I will be defining my window size, which is my largest window of 60 minutes. And then my window period is just 1 minute. So every 1 minute, I'm going to get a window of 1 hour. Then I will chop that 1 hour into 15 minutes, 30 minutes, and 1 hour. So I have defined auxiliary function and classes to be able to augment the data that I have. So the data that I have are just pretty much transaction ID, customer ID, terminal ID, and the amount. So I need to be able to process things in a Beam manner. So I will add more things to it. For example, this particular code is just to convert my timestamps into a units time. Then I have auxiliary functions to just bring the elements. Now here I have adding additional info. So instead of using the ID and terminal as it is, I'm creating a composite key using the terminal ID and the window at date time from the windows that we create from Beam. So by having that, I have 3 additional columns, which is customer ID composite key, terminal ID composite key, and also the time difference from the records to the window end time. Why do I need that? Because I need to create things. I need to filter the records based on the time that I have. So if they are falling within 15 minutes, I will use those data to create aggregation features. And if they are fall within 30 minutes, I will also do the same. And if they are falling within 60 minutes, I will do the same as well. So things I'm counting are number of transaction, number of amount, the sum amount, and I'm calculating the average by dividing with the number of transaction. So this is just to reformat for the output, and I will show you how it looks like on a batch data. So I have mentioned Apache Beam work for the same for batch and the streaming data. So in this case, I'm just trying out, right? So my initial thought was to try out with the batch of data. If my pipeline works for batch of data, I will replace my source with a streaming source. So once I replace it, it should work seamlessly for streaming as well. So this is the approach that I have taken. So I have a dummy data that initialized here. Then I create a pipeline with a flag. So if you are going to run Apache Beams on your local system, you can use this direct runner. So direct runner would run your code on local. So if you put direct runner, it will run things on local, and it will just put out all the information that you have. So this is the dummy data that I created. And once I use this to create beans, pipelines, you will see that beans can actually read in all this info here. So the next step is to enrich the data. Because my data only have 5 columns, I want to have more columns to work with the windows. So I'm attaching the timestamps so that I know I'm working with the records that based on that timestamps. I'm also creating a window functions using the sliding window and the offset that we mentioned on the slide just now. So window size is still 1 hour, window period is 1 minute, and I'm converting them into a tuple. So name tuple is like Beam data type, so that I could use more functions to it. So after I have enriched my source of data from 4 lines of records, it's become a numerous times of records, because it will create a duplicates, right? Because of the sliding window with offset, it will create a duplicates of all this thing. And I have all the composite key. So we have like customer ID with the date time of the window. So I could use this to figure out which records are within which time window. So once we have that, I just need to find aggregation functions to just aggregate back by doing a number count, by finding out the amount, by finding out the average of things. So I will use group by functions provided by Apache Beam. And then I will group by using the customer composite key. So this line is to just group by, and my aggregation fees are based on the time difference that we have. If the time difference is within 15 minutes, I will aggregate them into 15 minutes. Within 30 minutes, I will aggregate them into 30 minutes. And if they are within 60 minutes, I will aggregate them into 60 minutes. It's the same for calculating the sum amount. So after that, I will just do a left join with this aggregation and the newly recorded data. So every Windows will have 1 minute of new freshly made data from the stream. So I will just filter those 1 minute data using the time difference. So if time difference is within that 1 minute, I will consider those as new records. So now I have new records of 1 minute and all the aggregation that I can get for past 1 hour, 30 minutes and 15 minutes. All I need to do is to join them back by using co-group by key that provided by Beam. So Beam has co-group by key, and then you can filter it so that you sort of make a left join on the new records using the aggregator field. So the end result looks like this. So now I have transition ID, transition timestamps, customer ID, same as usual, but I have more additional records. So number of transitions that we get from 15 minutes, 30 minutes, and 60 minutes, and also the average amount that we get for 15 minutes, 30 minutes, and 60 minutes. And you can keep on creating more stuff based on your business use case or the problems. So we actually use days, like 7 days, 1 day, and 14 days in our actual project as well. But for the time being, this is quite good enough to demonstrate. So now I have this pipeline built for batch. I can reuse the code to actually create a streaming pipeline. So in order to have a streaming pipeline, what I need to do is I need to replace the source. So currently, I'm reading this from a pub/sub topic, which I have created for the Apache Beam's input. So it will just read from those pub/sub, and it will decode it into a dictionary. Then exactly the same steps that we did for batch, we will just do this for the streaming, and it will just work as per normal. So once this is working for direct runner, what I could do is I could run this for Dataflow. So if I'm going to run this particular piece of pipeline on Google Cloud, all we need to do is just create a main.py file, write everything that we have here, and change the direct runners to Dataflow runners. And then you just provide the project ID, the regions, and the temporary location, and define number of workers that you want to use. So that's about it. So just by changing these pipeline options, we are able to run this Dataflow pipeline, Apache Beam pipeline on Dataflow. So I have already run this particular thing, and is running here. So all the steps that we just did for like reading from the pub/sub, decoding from the byte, attaching the timestamp, creating the windows and things, filtering, grouping by, assigning key, all these steps are actually mapped out here, and you can see it virtually on what each step is doing. And since I'm also, printing it out on the reformat steps, you can also see the summary of all the features that we just created, right? So everything that we just received from the pipeline just now, we could see from the logs here as well. So that's pretty much what I have to share for today.